Okay, Jai Hind all. Myself, Dr. Sarika Kalra, Associate Professor in Ajay Kumar Garg Engineering College. So, good morning, my dear students. So, I am taking the one of the subject electric drive, the KEE 075, and the topic is chopper fed controlled DC separately excited motor, right? Chopper fed DC drive actually. So, in the last lecture, if you have go through the last lecture, we have discussed about the rectifier fed uh, control rectifier fed DC drives. Now we will do the chopper fed DC drive system. So there are many application of chopper fed DC drive system nowadays actually, like because now industry is more concerned with the electric vehicles. I mean all the kind of the fuel motors can converted into the electric motor, so that the pollution free environment can be created. So in this you can the battery like the chopper fed converters is used some of the EV systems, and it's actually basically it's used for the switch mode power supply. And so this is that's why this topic is very important the for the students, right? And it's a chopper fed control. So we discuss the motoring operation as well as the braking operation. Then we combine this two operation with the one circuit. We can easily get the motoring as well as the because with the help of the power electronics converter, now we can get the 4 quadrant operation or 2 quadrant operation in a single circuit, right? With the help of this switches, availability of switches, because these switches are based on the electronics, the mechanism is based on the electronic space, right? So this is the one of the circuit that will this is the one of the circuit, the chopper fed DC. Here I am using the DC separately excited motor where the flux is remain constant, and this circuit we are giving the DC supply with the help of chopper, right? Here we use the step down chopper, one thyristor, or sorry, one this switch is used. It can be a MOSFET or it can be a BJT depending upon the application used, right? Or depending upon the rating of the motor. Okay, and this is one diode has been used. It work as a freewheeling diode, and the one supplied the DC supply has been used. So this circuit will operate in the giving the motoring operation, and you can see it's a first quadrant operation where the voltage in the current is a positive, and you can say the speed and the torque is in positive, right? So if you see the operating principle behind it, we'll just see like the switch, because it's a switch mode kind of converter, so switch can be on or it can be off, right? So when the switch is on, the circuit become like this. This is the model of the DC separately, where the RA is the resistance of armature winding, the L is the inductance of armature winding, and the E the back EMF is which is induced in the DC motor. Flux remains constant because here I am using the separately excited DC motor. Now with this, now to understand the operation of this circuit, when the switch is on, the circuit will become closed. The diode is now reverse bias because positive is giving to the N junction. So it is reverse bias. So the circuit carry the voltage, the resistor, the motor, and the switch. So it will, the current is rising, the inductor will charge, and suppose the initial current is IA1, so it will increases and it will go up to IA2 suppose. So you'll get the voltage, the circuit become like this. So in first mode, if you see, when TR is on, the circuit now become carry the voltage source, the whole DC motor, and This is open circuit because now the diode is a reverse bias, right? So here the output voltage you are getting, or it is called armature voltage also, you are getting the same as the input voltage. So here you can see, and the voltage is connected, so the inductor will be charged so that the current will increases. Now suppose the initial current is IA1, so during T on period, when the switch is on, the current will rise from IA1 to IA2, and you are getting the voltage same as the input voltage. That's why here it is drawing like this. Now the second case, when the switch is off, when the TR is off during T off period, so the current which is the energy which is stored in the inductor is released through the diode, and which is in this direction, because now the diode will become forward biased, and the circuit is now, it's like this only, the supply is cut off from the circuit, and you are getting here the zero voltage, right? So that's why during T off, T on to T, you are getting the zero voltage, and the current is now decreasing in free will through the diode. So the current is suppose decreasing from IA2 to IA1. So the same cycle will repeated as the switching on switching off process is going on. So suppose the T is the time period of the circuit of the switch. So now the equation become, you can write the equation. So if you're able to find out the average value, so we can write the time period is 1 by T. So it can be written as 1 by T, 0 to T on, or you can write here, because from T on to T the voltage is 0, so I consider only the 0 to T on period, and the voltage is the input voltage, and this is, you are getting T on upon T V. So suppose this is called delta V. So delta is the duty ratio, and where T is the time period, and T on is the switching on time, switch on time. So this is you are getting the voltage at the input to the supply, input to the motor. Now if you see the equation which is related to your motor, the separately excited DC motor, if you have write down the motor equation, you will see that V right. So E can be written as, and speed can be written as E by phi, as you already know, E is equal to P phi n by 60 into ZA by A. So speed in radian per second can be written as, the K is constant, and here the flux is constant, so E can be replaced by like V minus VA, you can write here, some constant K. We considering this is suppose KA, so K is equal to KA phi, right? Now this is the simple equation which describe the relation between the speed of the motor and the voltage, the armature voltage in IR also, and we can replace now K phi as K, because phi is now constant because we are using the separately excited motor, right? Now You can see that when we use a chopper fed DC motor, now VA can be replaced by, because you are getting here the voltage VA, that is average value, VA is now delta V, right? So omega m can be written as delta V minus IARA upon K, some constant K, right? Now you already know the relation between the torque and the current. T is equal to K phi Ia, which is this equation related to your motor. So it can be proportional to, the torque can be proportional to K Ia. So this Ia can be replaced by T by I. So in this equation 1, suppose equation A, Ia is replaced by torque, because now we have to find out the relation between the torque and speed, and we'll see how the motoring operation will be fine. So our aim is to draw the speed torque characteristic for chopper fed DC drive system. That's why we are getting the here we are finding the relation between the speed and torque. So we are replacing Ia by torque with the help of this equation, right? So omega m is the speed of the rotor, delta V, because you are feeding the voltage with the help of chopper, so here the delta V is there. Now this is Ia can be replaced by, so here the K and here the K square. So this is relation, final relation we will find in this way. Now we are trying to draw the speed torque characteristic, and with the help of chopper, how we'll do this, how the motoring operation will be performed. Suppose this is torque and this is speed, right? So at no load, this term will be 0, so you are getting the no load speed will be this much, right? So at no load, the speed will be okay. Omega m0 is equal to delta V by K. So omega m0 is equal to delta V by K. So it's at no load, right? Now as the torque will increases, because it's a straight line equation, so you can draw the like this characteristic, right? Correct. Now this is for at particular delta value, alright. Now when the delta is increases or delta is reduces, your no load speed will get reduced, so you'll get the another characteristic, right? When you because DC separately excited motor generally used for the the constant speed drive. Now with the help of using the chopper fed, we are now getting the variable speed torque drive, right? Now you're getting the variable speed. So this is the big advantage of this circuit, and now you are getting this kind of. So as the delta increases, right, and you're getting the positive torque, right? So no load speed जब when you are increasing the load, your speed will decrease, and here the IA is positive, because in this circuit you will see the direction of the current will be like this only. When the switch is on, the current will flow in this direction, that is IA1. Suppose IA1, it is rising to IA2, because it is when the current is, when the device will be turn off, it is free wheel, so it is like this is diode, so it is free wheel through this, and the direction of the current will be same, right? So the torque will be same. So you are getting the IA positive current and the positive voltage, and in this case you are getting the, if you are getting the positive current, so positive torque, so your speed torque characteristic will be in, the torque will be in first quadrant, right? So you are now achieving the motoring operation with the help of this circuit, right? And the speed, and with the help of delta you can now vary the characteristic. So now the at different value of delta you are getting the different characteristic. As the delta increases, this value get increases, so your characteristic will shift towards this way. So this is how with the help of this chopper fed you are getting the different characters, different speed variation. So this is the main advantage of the circuit, right? Now we coming to regenerative brake. This is a circuit of regenerative braking. How will achieve the braking or regenerative braking with the help of the circuit, right? It is also the chopper fed DC drive circuit, and regenerative braking means you are feeding the power from load to the source, right? So that it can operate the braking operation, so all the energy will be flow from load to the source, right? So in this way the current is when the current is flowing in the opposite direction, your torque will become reverse, and now the operation will be performed in the second quadrant operation, where the torque is negative, the speed is remain the same direction. So if the omega is positive and the torque is negative, it is operate in the second quadrant operation, right? It is operate in the second quadrant operation, and uh, it is performing the braking operation. And why it is regenerative? Because it is giving the power from, feeding the power from load to the source. That's why it is called the regenerative braking. Why braking operation will be performed? Because now the current will be flowing in the reverse direction, and the torque will be now negative in the opposite direction. Now it will perform second quadrant operation, so the braking operation will be formed. If you recall the four quadrant operation, this is like first quadrant, suppose this is T, this is torque, this is speed. So it is first quadrant, second quadrant, this is third quadrant, and this is fourth quadrant. So this is forward motoring, you can say. These are the standard convention of torque and the speed. This is braking, forward braking, you can say, right? Here the speed and the torque will both are negative, so it is reverse braking, reverse motoring, and in fourth quadrant it is reverse braking. So with the help of this circuit you are achieving the forward braking operation. And why it is regenerative? Because it is feeding power from load to the source. The current will flowing from this motor to the supply side. So if the current is negative, the torque is become negative, but the speed direction will be same. So it is operating. That's why it is operating in the forward braking operation in the second quadrant. Now we'll try to understand the operation of the operation of the circuit. So because it's a switch mode circuit, so one switch is required here. It can be a MOSFET, it can be a BJT, or it can be a IGBT. So depending upon the what is the rating of the motor and what kind of load you are running, and so and this one diode is required, and this is the voltage source, DC supply, and this is a capacitor to maintain the voltage constant, right? Now this is the model of DC motor, separately excited, we assume here. Now, so it is separately excited, that's why the fluxes remain constant, and we uh, assume that the flux is constant. So this RA is the armature resistance, the winding resistance of armature, and this is the leakage reactance of the armature. This is the EMF, back EMF, which is induced in the armature circuit. So this is the model of the DC motor, right? Now, when the switch is on, I just make the circuit again here so that it is convenient to you. Now we're trying to find out the average value of the circuit. This is T, this is D. Now when the switch is on, when TR is on, suppose this is TR. So when the TR is on, so when TR is on, because this is blocking the current, now it is reverse bias because of this supply, and the current now the when this is on circuit, so the circuit now become this way, and the current, this is the back EMF, so the inductor will be charged through this back EMF and the current will flow in this direction, right? So now the current is rising because it is charging the inductor, right? So suppose the current is IA1 and the current now become IA2, but during that period the voltage is 0 till now. Suppose the voltage is 0 during T to T on. Now after when the switch is off, when TR is off, the circuit become, because now the capacitor is this inductor is charged. Now the current, the energy stored in the inductor will be releasing through this diode, and the current direction will be in opposite, and now the power is feeding from this DC circuit to the voltage source, right? Now you are getting the voltage here, it's equal to V, the input voltage, and the direction of the current is now opposite. So direction of current is, now it is in, if you see previously, the direction of the current is in this direction. If it is a, you are assuming that it is a positive current, so according to the taking reference that current, it is the negative current, right? So this is the voltage. Again the same cycle will repeat, and your current will be like this, right, rising, then decreasing, then rising. Suppose IA12, between IA1 to I1. So during switch on, the current will rise from IA1 to IA2, and during switch off, the current will decreases from IA2 to IA1. So it is decreasing, it is increasing, right? So this is T, right? So now we'll see that average value will be here also. You can see this, the same diagram is drawn here also, right? So this is the diagram, same diagram is so now we'll find out the average value. So here the duty ratio is T minus T on upon T. So this is duty ratio delta, suppose. So V is equal to 1 upon T, T minus T on multiply by V. So it can be the T minus T on by T can be replaced by V, delta V. So with the help of this, if you use the same equation, equation, the speed torque characteristic, taking this equation and try to put the VA value in terms of the circuit, right? So omega m is equal to V minus K minus T upon K square RA. Here T is equal to minus KIA because now the current is negative, right? So replace this voltage. This voltage is right, U V K, and this is T K square RA. So T can be replaced by like minus T, so it can be a positive. So if you are able to if you are going to draw the speed torque characteristic, you will see that now if you see the no load speed, when the torque is 0, you are getting the no load speed will be delta V by K with respect to T is equal to 0 at no load, right? So suppose the point will be here. This is suppose the no load speed, that is represented by omega m0. Now as the torque is increases, because the current is now negative, so your torque will be negative and the overall this term will increases, right? So as the torque will increases, the speed will getting the above the no load speed, right? So this kind of characteristic you are getting. Then again at different value of delta, this kind of characteristic getting. Then again, so this is no load speed with different load, and this is delta increasing, right? So here you can see that the speed is positive, right, but the torque is negative. So torque is now you are getting the negative torque and the speed is positive because your current is now flowing in the opposite direction, or it is feeding power from source load to the source. So it will creating the regenerative braking operation, because now the torque will be negative and the speed is positive, right? So here you are getting the speed positive. So at no load you will see, because it's a straight line equation, right? So at no load T is negative, so speed will be positive and you are getting the delta V by K positive speed, and as the torque load increases, your speed will be above the rated speed. So this kind of characteristic you are getting, and these different characteristic because your delta is varying now, right? At different value of delta, suppose this is at delta 1, this is at delta 2, and this is at delta 3. So delta vary between 0 to 1. It is at dt ratio T on by T, right? So this kind of, so in this mode of operation, you are getting the braking operation and regenerative braking. So if you combine these two circuit in one, because now in this we see that one different circuit will get the motoring operation, and another circuit you are getting the braking operation, regenerative. If you combine this two circuit with the one whole circuit, you are getting the braking operation as well as the regenerating operation by simply changing the switching of the switches, right? So and this is the big advantage of the power electronic circuit based drive system, because with the help of only just by varying the duty ratio, you'll get the motoring operation as well as the braking operation, right? So when we combine these two circuit, we'll get in a single circuit, you'll see that the motoring and braking operation will be getting with only by changing the duty ratio, right? So we'll see in the next, we'll see. Sorry, this is not a rectifier base, this is chopper based. So now in the next coming lecture, we'll see that the both we combine this both circuit, and we'll see that with the single circuit we are getting the motoring as well as the regenerating operation. Thank you.